Alright, welcome back to another video on Node.js, particularly on socket. So, looking at this section, okay, and understanding one of the exciting features of the internet, at least to me, and the fundamental of that is socket. So, imagine that we're going to build a chat application with all the things that we already know, right? So, if we want to send a post request, if we want to send a message, we use a HTTP post request. If we want to read message, we use a GET request. The question is that when do we know to fetch data? So when is the right time to fetch data from the client perspective? Or is there even a right time of period to do that? Doesn't the data depend how often it changes? In other words, doesn't this depend how often the data change on the server? For example, data that is outside of our control, data that we didn't create, for example, in our chat app, if a friend sent a message to us, it create that message. So data that might be in their own life cycle, so for example, self-driving car or trading or games. So most of the time for this kind of situation, we deal with following is the pooling approach, which consists on sending GET requests so often in a period of time, and when that time has passed, we send a new GET request in a loop essentially. So this approach, when using is the set interval JavaScript features, and define is the pool rate, right, by 500 milliseconds, we're going to add 500 millisecond delay to all updates. However, for a chat application, this might be okay, but for the real stuff, like self-driving car, trading, or games, might not be feasible. But for our case, we just not have that challenge of the adding 500 millisecond delay of all updates, but also here we're adding is 2 requests per second, 120 requests per minute, meaning that we're flooding the server with incoming requests for just one single server client. And imagine that if we want to have several users, 110,000 users, so or you need a very powerful server or a different approach, WebSocket to the rescue. So after all, socket from the plain definition of Merriam-Webster, so sockets are opening in the computer system that in which you can connect to form a in which you can connect to send or receive message. So these data sockets are holders for this type of connection in network computers. And when I talk about computer systems, okay, which are programmable machines that performs arithmetic and logic operations, and the system means that these machines are made of hardware, software, and its peripheral. So, such as that, in the case of desktop, the keyboard, mouse, monitor, speakers, but in the laptop you have everything built in. And what I mean by computer networks is a series of computers sharing resources located on or provided by network node. When we talk about this located on, we can think of them similar as people. If we think of them, if the server or a computer is similar as the people, which after all they exchange, in the case of humans, literature, music, fluids, Yeah, in exchange, yeah, in the case of human Jesus, it's like I recently woke up, so yeah, that's not an excuse. Move on. So if we take that analogy, okay, from the computer system and what is these computer networks on the real life, such as if we see ourselves as a computer, okay, we constantly exchange is love, knowledge, culture, fluids, insults, you name it, right? So this computer now share resource, okay, and they, for example, in these network computers, they can be either at redistribution points, such as this BGP protocol, border gateway protocol. But what it does is just to routing or exchange routing data from one autonomous system to another. An interconnected network of computers that operate under a single admin domain. For example, Google, Facebook, Twitter, um, Akamai, Amazon, Cloudflare, very soon. So okay, uh, so we can think of them somewhat similar as the people living in a country. All right. So that's one capability of the network, or yeah, a network computer. So there can be either a redistribution point or a communication endpoint, which is an address that identify an communication entity, such as your desktop server, firewall, a router, switch. Okay, so any of the device on the internet. Okay, so knowing that the internet now is made of this billion and billion of connections, the TCP or the IP socket particularly is the basic building block, and on top of that you have is datagram sockets, where now here low latency is the most important factors, and TCP sockets, where now reliability is the most important factors. So before you send and receive message, you need to connect, which is they are connection based, and you can know if a message you send was received or not. Okay, reliability. And on top of the TCP connection, we have is the HTTP and WebSocket, where now HTTP is by far the common protocol that we have used, okay, to fetch data from our server, and WebSocket is a JavaScript feature that backend developers and web developers must know, and it allows this two-way, real-time, bidirectional communication between the user browser and the server. So now that we understand this and the subtle difference between the socket and polling, which with the polling, the client needs to make recurring get requests to the server, but now with socket, it open a channel between the user browser and the server to allow this uh, communications to happen, these two-way communications to happen. And this is something powerful and revolutionary, because now the client doesn't need to guess when to send data, and the responsibility is now on the server to keep the client up to date. And now the client doesn't need to guess when to fetch data, okay, or when is the right time to fetch data. So similar as the HTTP, where we have several implementations like no fetch or Axios, which indicates how to fetch data from the server. WebSocket has similar implementations like WS that only works on the server, and if you want to make that happen on the browser, you might rely on WebSocket API or any other non-popular library. The only trade-off is that if the browser doesn't support WebSocket, you cannot establish that. And there is some mismatch in the API interface between the WS on Node and the WebSocket. So there's a convenient library called socket.io that give us a unified interface and fallback. So this socket.io is an extremely popular library that enables the real-time bidirectional event-driven communications that works on any platform. And that's good because professionals like Microsoft Office and Trello use that. So when I look at the socket.io, the anatomy of the socket.io, okay, we have the client, the browser, and the server. Even though that they have different responsibility, we don't need to juggle in between different API sets or with different functionalities. We can focus on building our app code while saving brain power as opposed to hunting bugs and worrying about compatibilities, which after all, you're going to deal with bugs. But if you can minimize that 10 to 20%, that saves you a lot of time. And also, a very important feature is that when you're building large production scale application, okay. So when you're building large scale productions applications, fallback is something important, especially in corporate environments. So socket.io on the client side, anytime you start that, it will attempt to make a WebSocket connection. And if your browser is one of those less 3% that doesn't support WebSocket, it will stick to a form of HTTP polling. And with that, we guarantee that our application works anywhere. Okay. So then I look at what are the different roles that the client and the server has. Okay. And that is, so from the client, it always connect or communicate to the server. But now the server needs to keep the client up to date, keep track the connected client, send messages directly or individually, send messages to a group of connected client, or broadcast to all connected clients. So I look at the common way of doing that, or this type of most common operations on the socket.io, which is only one line, in compare with the WS API, where now here you have several lines of code. So then, now that I saw all of that theory, okay, about what is sockets, the plain definition of sockets, what is the use case when we want to use socket, for example, a chat app, or for more realistic or for the real stuff, we want to use this like self-driving car. Yeah, like self-driving cars, trading or games, right? And then I look at the subtle difference of or understand the concept of pooling. example of pooling, the subtle difference between the socket, or not that subtle, the difference between socket and pooling, implementations of HTTP and WebSockets, and why do we choose socket.io over all the other WebSocket implementations, the anatomy of the WebSockets, which is the client and the server, the responsibility of each role, and now look at the difference of socket.io versus the WS, and start to apply all of the theory by building a multiplayer Pong game. If you're not familiar with that, well, this is one of the first video game released in 1972, 3 years after the ARPANET. Okay, and it was created by a company called Atari on a massive carry. But inspecting the code, okay, the TLDR, okay, is games has something called the game loop. So from basic game like Tetris or Pong to a more modern games like Fortnite or Minecraft, all of them have something called game loop. Okay, and understanding how we're going to set up that in setting up a socket.io server, a socket.io client, handling events. Okay, listen to events on the server side, listen to events on the client side, handling events on the server and on the client. Okay, and then take a closer look at implementation of the game logic here, like padding and bolts, right? Very narrow specific here. So, and also describe what happens when you disconnect. Okay, and what is the behavior, the default behavior. Now, because we want us to serve this content statically in our server, we integrate Express with socket.io, and that was something very, very beautiful to see, because we define is a bare bones Express app that in there we're going to define several basic middlewares. First is to indicate that express static, where is the file we're going to look for, what is the folder we're going to set as the root directory. Okay, and on the root directory we're going to serve is the index.html file. And then how we can connect is our Express app with our socket.io server by abstracting is the connection or the socket logic into its own file. And then on the server file, we're going to install is, we're just going to call is the API server, which split out here our server for readability, our API server, the HTTP server, and the socket server. And the reason why we do this is for versatility and for flexibility. Because let's say we want us to implement now an HTTPS server. Okay, now with this setup we can easily do that. And also something that is hard in computer science is catching validation and naming things. According to Phil Carton, who works of one of the first browsers. Okay, so Phil Carton works of one of the first web browsers, Netscape. Okay, And after that, then I look at two concepts, namespace and rooms. So namespace, which is a very common definition or concept on software engineer, okay, or computer science. Two of the most common advanced features from Socket.io is namespace and rooms. So namespace allows you to separate concern about Socket server by introducing new endpoints. So in other words, namespace allows you to separate the code concerned, in this case, to the Socket server by introducing new endpoints. And the client can connect for different tasks with different level of permissions, or something, or sometimes, or something completely, or with completely different applications. Okay, so this is the core concept of the namespace. Okay, it allows you to separate code concern to a particular role or server by introducing new endpoints that the client can connect to, or that the client can connect to for different tasks with different permissions roles or with completely different applications. And this distinction is something important with namespace. This distinction is very, very important. So for example, we have an administrator task that only them can perform. We can separate that with different namespace in our server, or if again server and want to host multiplayer Pong applications alongside with multiplayer Tetris application. So we have these two examples, right? So we have an administrator task that can only that only them can perform. So we separate that with a different namespace. Or if I had a game server and want to host multiple different applications like a Pong or Tetris, we create namespace for that. And the client can choose which of the namespace can communicate. So for simplicity, then most of the time we use only one single namespace for simplicity. And that's exactly where we are here with Node.js. What is this? Okay. Socket here. And namespace.
Two of the most common advanced features that we get from Socket.io.
Okay. I can barely hear now. So what I'm gonna do here is disconnect a little bit the microphone here for this.
Are namespaces and rooms. Let's start by talking about our first advanced feature of namespaces, which we can see is a communication channel that allows you to split the logic of your application over a shared single connection. What does this mean? Tetris application, for example. If we don't explicitly create a namespace, Socket.io will use the default namespace, which we can see on the client side when we connect to our Socket server if we specify this first parameter when we connect. And we say that the / or the root endpoint, which represents the default namespace, is the one we're connecting to. Now I can start my server and load my Pong game, and it connects. Now, if I wanted to add an explicit namespace for Pong, so that I could then create future namespaces for different games or, say, a chat, I would specify the name of the namespace when I connect to Socket.io on the client side. And on the server side, I would create a new namespace by creating a variable for the namespace, say Pong namespace. And we would use this io.of function to pass in the name of the custom namespace that we want to create. So in our case, we decided on Pong. Now, any of the functions that we call on the io scope, on the io object over here, we can narrow down to the Pong namespace. So in this case, if we replace io with Pong namespace, we're saying that only on the connection to the Pong namespace do we respond to the ready event with a player ready message and starting the game. And when we emit, in this case, the broadcast to all connected clients, and we narrow it down to the Pong namespace, we're now broadcasting only to the clients that have connected to this namespace, like we did in our front-end code over here. And the rest of our actions here, on our socket, for example, now act on sockets for clients that have connected to our custom namespace. Now, if we built a Tetris game, in addition to our Pong game, we would then connect to our Tetris namespace instead of Pong, and we could create a corresponding set of event handlers by creating our Tetris namespace and calling the io.of function on the name of that namespace, so say Tetris. Now I could host multiple games on the same web server over here, and Socket.io would be smart enough to share a single pipe or a single shared connection when talking to the different namespaces, while still giving us that separation of concerns that we need when building large-scale systems. All right, let's talk about rooms in the next video. I'll see you then. Let's look at the most important advanced feature that we get from Socket.io. which is rooms. Say we wanted to create a Pong server that supports many users joining and having multiple multiplayer Pong games running at the same time. We could create game lobbies, which players can connect to while they're waiting for a game to start and for another player to join. And we could communicate with the other players in those lobbies. And when ready, start our game of Pong. This is all possible with these core features of Socket.io, such as namespaces and rooms, that are not available with the native WebSocket functionality. So what are rooms? Rooms are a way of further dividing Socket.io namespaces, which we saw previously, into groupings of sockets. Instead of namespaces, which we saw previously, we get from Socket.io, which is rooms. Say we wanted to create a Pong server that supports many users joining. And having, which is rooms. Say we wanted to create a Pong server that supports many users joining and having multiple multiplayer Pong games running at the same time. We could create game lobbies, which players can connect to while they're waiting for a game to start and for another at the same time. We could create game lobbies, which players can connect to while they're waiting for a game to start. And for another player to join. And we could communicate with the other players in those lobbies. While they're waiting for a game to start and for another player to join. And we could communicate with the other players in those lobbies. And when ready, start our game of Pong. This is all possible with these core features of Socket.io, such as namespaces and rooms, that are not all possible with these core features of Socket.io, such as namespaces and rooms, that are not. This is all possible with these core features of Socket.io, such as namespaces and rooms, that are not available with these core features of Socket.io, such as namespaces and rooms, that are not available with the native WebSocket functionality. So what are rooms? Rooms are a way of further dividing Socket.io namespaces, which we saw previously, into groupings of sockets. Instead of dividing our socket server by separating functionality by endpoint, for example with our Pong endpoint, we instead divide our socket server by groups of clients or sockets that are connected to it. So, core features of Socket.io, such as namespaces and rooms, that are not available with the native WebSocket functionality. So what are rooms? Rooms are a way of further dividing Socket.io namespaces, which we saw. So what are rooms? Rooms are a way of further dividing Socket.io namespaces, which we saw previously, into groupings of sockets. Instead of dividing our socket server by separating functionality, by endpoint, for example with our Pong endpoint, we instead divide our socket server by groups of clients for example with our Pong endpoint, we instead divide our socket server by groups of clients or sockets that are connected to it. And these groupings only exist on the server. The client knows nothing about them. In fact, by default, each socket over here gets its own room. So if we don't explicitly join a room on the server, each socket is separate. And this grouping of clients by room explicitly them. In fact, by default, each socket over here gets its own room. So if we don't explicitly join a room on the server, each socket is separate. And this gets its own room. So if we don't explicitly join a room on the server, each socket is separate, and this grouping of clients by room has no meaning. But say we wanted to introduce these groupings of clients, and we wanted each pair of players that's ready to start the game to have their own room to play a game of Pong. We would want the players to join a room when they let us know that they're ready to start and that they've loaded the Pong game, which is when we receive this ready event. And the way we join a room in Socket.io is to call this join function on our socket object. And we pass in the name of the room that we want to join. So how are we going to name our rooms? How do we know which player should join which room? Well, we can create a variable called room, and we'll say each room's name starts with the word room, followed by the number of the room, which we want to be the ready player count divided by 2, because each pair of players is going to have one room. But we want this to be integer division. We want 1 divided by 2 to be 0, and not 0.5, so that the first player who's ready, when the ready player count is 0, joins room 0 divided by 2, so 0, and then the second player who's ready, which will be when the ready player count is 1, will join room 1 divided by 2 in integer division without that decimal spot, which we'll do with this math.floor function. So now, when the ready player count is 1 for the second player who's joining, prior to the count being increased, that player will join room 1 divided by 2, 0.5, and then floored, so remove the decimal points, and it will join room 0, just like the first player. So using this strategy, we can group players into pairs, where each room holds a pair of players. And we can leave our rooms when our client disconnects, and we receive the disconnect message. And the way we leave a room is similarly socket.leave, passing in the name of the room. We want to do this so our rooms don't stick around forever. But Socket.io already removes us from a room when we disconnect by default. So we're just doing this here to be explicit. Okay, but wait, we don't have access to this room variable in this scope over here. It's declared only when we're ready. So let's move this room variable and keep it around for the scope of the entire connection. And we can log the room that the player joins when they ready up. Now we want to update our broadcast messages. Rather than broadcasting to the entire namespace for our Pong game, we want to broadcast just to all the clients in our room. If we go back to our handy emit cheat sheet and we scroll down here, we can see that to send to all clients in our room, including the sender, we want to use this in function of the IO object. And in fact, all of the functions that the IO object has apply to each individual namespace. So we'll want to call emit on our Pong namespace, calling the in function on our room. So we'll do Pong namespace dot in room dot emit start game. This will broadcast to all the clients that have connected to this room. And we'll want to do something similar for our paddle and ball movement broadcasts. Rather than calling the socket.broadcast.emit function to emit to all the clients without specifying a room, we'll call the socket.to function and emit on that room. This is how we send to all the clients in the game room, except for the sender. So we're doing the same as before, but narrowing our message to that specific room. So we'll replace broadcast with to, and then the name of the room. Similarly for the ball move event. Just like that, our server now supports multiple rooms with multiple games of Pong happening side by side. If we wanted to test this, we could start our server back up, and on our client side, join our first room. So we have our first client ready, our second client should become ready, and the room begins the game. Let's get a few points on the board. And when I refreshed, the two clients, or the two tabs that I refreshed, disconnected from the game, and then subsequently reconnected. And now we could be extended to as many games of Pong across the internet as we wanted. Rooms have allowed our server to scale to as many games as we wanted. They model real-world applications, like chat rooms and game lobbies, very well. And unlike namespaces, rooms can be introduced, joined, And this can
And well, that'll be all for this video. Take care. Bye bye.